Hello, welcome to test classes. Today in this class we will study about root locus. Root locus is the most important chapter in the control system. Okay, let's start our class. First of all, we will study what is the root locus. Root locus means it is a graphical method to test the stability of a control system dynamically. Dynamically means if the value of k changes. That means if the roots are changes from one place to another place in that region, we will test the stability of the control system graphically. This process is known as root locus process. Definition part is over. Next we will go for placement part. In placement, where the root locus is started, where it is placed and where it will be ended. First, root locus is always symmetrical to the real axis. We know that it is real axis is S and S, and the imaginary axis J omega. So the root locus is always symmetrical to x axis, that is symmetrical to real axis. That means the part which is as usual to the upper side of the S plane, that will be same as to the lower side of the S plane. That means it is symmetrical to x axis or symmetrical to the real axis. The next point is where the point is started. The root locus is always started from a open loop pole and ended either at a open loop 0 or at infinity. Okay, it means it has the starting point is open loop pole, but the ending point is maybe two types, either maybe open loop 0 or maybe at infinity. We have studied the pole and 0. If in a root locus the number of pole and number of 0, if the number of pole is greater than number of 0, then the branch is always terminate at infinity. If the pole is less than the value of 0, that means if the zeros are 5 and pole are 3, that means if the zeros number are more than the number of the pole, then the branch is always started at infinity. We have studied what is the starting point and ending point. Now we will study where the region is. Suppose this is the S plane and number of poles. Suppose one pole is here, one pole is here and one pole is here. From if you are moving from origin to the left side, where the control, where the root locus will establish and where it will not. Suppose we are moving in the left side. That means at this place we have seen that only one pole right hand side after this pole. That means if the number of pole and 0 from one point towards the origin is odd, then within this region the root locus is exist. That means from this point to this point, within these limits the root locus may exist, but from this point to this point, within this point, if I am taking the point is here, and after then if I am going towards the right side, then I can see that two number of pole at the RHS of this point. That means 2 is the even. So within from this limit to this limit, within these two limits there is no root locus will be present. But after from this point towards LHS, if I take any point is here, then I can see that from that point towards the right hand side there is the 3 poles. That means the odd number of poles there. So within this region there can be established the root locus points. The next point is total loci. That means how many locus are present inside a root locus. Suppose in a root locus the number of pole is 5 and number of 0 is z is equal to 3. Suppose in a root locus we have 5 number of pole and 3 number of 0, then the total loci will be maximum value of pole and 0. That means within the pole and 0, which is the maximum in number. In this example I have pole is 5 and 0 is 3. So number of pole is equal to 5. So for this question the number of loci will be 5 is here. The maximum between the pole and 0 is known as the total number of loci. Next we go for number of asymptote. Number of asymptote means in the question we have got pole and 0 values. Number of pole and number of 0 value. The number of asymptote means how many number of pole are there minus how many number of 0 are there. The difference between the number of pole and number of 0 is known as the number of asymptote. If the number of 0 is more and pole is less, then the number of asymptote will be number of 0 minus number of pole. This is the number of asymptote. It is the difference, it is the numerical difference between the pole and zeros. Next, the centroid. Now we will study with a particular example. Let's g of s is equal to s divided by s plus 1 into s plus 2. This is the only g of s. At h of s is here, unit feedback. Unit feedback is here. That means here g of s is equal to s divided by s plus 1 into s plus 2. So I will study here the number of loci. Here the number of pole is equal to 2. That is s is equal to minus 1 and s is equal to minus 2. These are the two number of the poles, and the number of 0 is here 1. That is at s is equal to 0. Here I have studied that at s is equal to 0, it is 1 0, s is equal to minus 1, 1 pole, and the second pole is that s is equal to minus 2. So now we will go for the centroid. Centroid formula is C is equal to summation of the number of poles, summation of the value of the real pole. Real pole means s is equal to minus 1, it is a real pole, s is equal to minus 2, it is a real pole. So its summation is minus 1 plus minus 2. Summation of the real poles minus summation of the zeros. Summation of 0 is s is equal to 0, so minus 0 divided by the number of pole minus number of 0. The number of pole is here 2 minus 1, 2 minus 1. So that means the value for the centroid is here is minus 3 by 1, which is equal to minus 3. So minus 3 is the centroid of the root locus. That means the formula for centroid is summation of poles minus summation of 0 divided by number of pole minus number of zeros. This is the formula for the centroid. Now we will go for angle of asymptote. The formula for angle of asymptote theta, which is equal to q, theta is equal to 2q plus 1 into 180 degree divided by p minus z. It has another formula, that is in case of p minus z, I can put z minus p. This formula is applicable when the number of pole is greater than the number of 0, and this formula is applicable when the number of 0 is greater than the number of pole. And here one important thing, that is the value of q. What is the value of q? The value of q is lies between from 0 to 1, 2. It will started from 0 and ended at pole minus 0. The difference between the pole and 0 minus 1 value. In the previous question, what we have done is that the number of 0 is 1, number of pole is 2. So p minus z minus 1, that is equal to 2 minus 1 minus 1 is equal to 0. From 0 to 0, that means q is equal to 0 was here. Only the value of q is 0. So the value of the theta will be 2 into 0 plus 1 into 180 degree divided by 2 minus 1, which is equal to 180 degree only. The angle of asymptote for this question is 180 degree. Next we will go for breakaway point. This is the breakaway point in case of pole, and this is the break in point in place of 0. And the value of breakaway or break-in point can be found out by a particular process, and the process is that we have the value of g of s and h of s. In the most of the cases, h of s is 1. So we have to find the characteristic equation, that is equal to 1 plus g of s into h of s is equal to 0. From this characteristic equation, we have to find d by ds of k is equal to 0. By putting the value of dk by ds is equal to 0, I will find the value of s. The value of s. The value of the s is known as the breakaway point. From the dk by ds is equal to 0, by equating it 0, the value of s, what we get, that is the breakaway point for a root locus. Next we will go for angle of differential. Angle of differential means the break at the point of breakaway. Suppose this is a point of breakaway. In this point, at what angle the asymptotes are intersect to this point? Suppose the angle is 60 degree and 120 degree. That means one asymptote will intersect it at 60 degree. If it is 120 degree, so another asymptote will intersect this point at 120 degree. Now we will go for intersection to imaginary axis. For this, I have to do some certain steps. The first step is that I have to get the characteristics equation. The characteristics equation, and the equation is 1 plus g of s into h of s is equal to 0. The first step is characteristics equation. The next step is to put the characteristics equation in the Routh array criteria by putting in Routh array criteria. And the third point will be, from this Routh array criteria we have to find the value of k for the which value the system is marginally stable. Now we have to write for marginally stable k's value, k value to be find out. We have to find the value of k for which the system is to be marginally stable, and that value will put in the characteristic equation, and the k is put in characteristics equation, and we will get a equation of s, and this equation is the value of s I got is the intersection to the imaginary axis. The point we will get from by putting the value of k in the characteristics equation and equating to 0, the value of s we get is the intersection point to the imaginary axis. And the last point is construction of root locus. By finding all these points, I will construct the root locus. And the next class I will do with a particular example and do all the steps and elaborate you about the construction of root locus. Thank you.